Happy Monday, my favourite lower sixth class. Okay, I wanted to quickly take you through some of the features on your calculator that you'll need to use, and you'll need to use them from this exercise onwards. You need to make sure that you can put your calculator or recognise your calculator is in Radians mode or degrees mode. And the trick here is to look in the top line of your calculator. A D stands for degrees and an R stands for radians. So that's the quick one glance way that I want you all to be able to look at your calculators and say it's in degrees or it's in radians. It will be one of the first questions I ask you if you come to me asking for help. Is your calculator in the right mode? Okay, next I'm going to show you how to put the calculator into degrees mode or into radians mode and move between the two. So if I have my calculator in front of me and I'm in degrees mode, I press shift mode/setup and then press the number for the radians mode, which is number 4. And there, I'm done. I'm in radians mode, and you can tell by the R in the top line of your screen. And to go back, shift mode and choose degrees, and degrees back. Okay, the most basic style of equation is just repeated here. This time we are using radians. Otherwise everything is the same. You just need your calculator in radians mode and an awareness that 2 pi is the same as a complete circle rather than 360. So as you can see on the screen, we're just solving as we would have done in the first pure book. We need to use the cast diagram or the drawing of curves, in this case the tan curve, to locate any extra solutions. So those are our two positive values of tan in the cast diagram. 0.54 fits nicely into the first quarter, and we need to add 0.54 to pi, because we're not adding it to 180, we're adding it to pi. That's what 180 degrees is, and that gives us our second solution. And it literally is as straightforward as that. We are only dealing in different measures of angles. So that's it. These are our two answers. We're also going to see quadratic trig questions again. Now I know what you're thinking. You're thinking, brilliant, I love these. And you'll be right, these are incredibly good fun. And we solved them exactly as we did in the first book. The only difference being this fine detail up in the top right. The fact that theta is in terms of pi means that it must be in radians. And we go through and we solve as we usually would. Our calculators must be in radians mode. Okay, so doing the inverse sine values, we are going to be coming out with two quite nice values, I think. We get negative 6 pi coming out, so that's an angle in the negative direction. And you mark it on just as you would mark on a negative 20 degrees. And then we are adding or subtracting that to pi and 2 pi respectively. So our first solution is a straight line plus 1/6 of pi. That's pi is a straight line, so 7 over 6 pi. And then taking 1/6 of pi away from 2 pi gives us 11/6 of pi. And those are two of our solutions. Then if we do it to sine theta equals 1, we get a value that goes straight up on the y-axis in our cast diagram. And if we do a reflection of that, we actually get the exact same line. So both solution lines overlap each other. Sine theta equals 1 only has one solution within the full circle, and that is half pi. And that is our full solution. We can't get any other solutions going around all the way around in a circle, so we are done. Okay, the final thing I want to talk to you about is when the function inside the trig function is something other than just x or theta. So as you see on the board, it's the exact kind of question we want to look at. We're going to get multiple solutions out of a cast diagram, as we usually do. Our calculator spits out the number 1.2309 and change. Now we're going to mark this on the cast diagram. Remembering cos is positive, so that's where cos is positive. 1.23 is marked on. And so our solutions to 3x minus 1 over 2 are going to be, and we're going to be starting with 1.23, and we're going to be finding all the multiple solutions first, all of them. Now this is the same method that we've used before. What I'm doing now is I'm starting with the original domain of x, and I'm extending that out to make the domain of the thing that we're finding multiple solutions of, which is 3x minus 1 over 2. And you can see the right hand side, the upper limit turns into this number 6 pi minus 1 over 2, which is roughly 8.925, which I get from just doing it in my calculator. Now, if I write out my multiple solutions here, I've got 1.3, or roughly 1.3, 2 pi minus 1.3, 2 pi add 1.3, and those are the numbers coming up on the board. Then our fourth one would be 4 pi subtract 1.23. So that last value we're going to check. It comes out as 11.3, which is too big. It has to be under 8.925, which the other three are. So those are our three solutions. Now, we're going to solve moving down. We'll have a calculator in hand and we'd put in 1.23096. We times it by 2. We subtract 1. Excuse me, we add 1. And we divide by 3. And working down the page, this is part of the reason why it's so critical that you're working down the page when you're solving equations and not doing something that's younger in style. Next, we put a comma after each and we look at 5.5223 and we put it in our calculator and we do the same things that we've just done. We multiply by 2 for the first step. We add 1 for the next step. And then we're going to be dividing by 3 for the final step. So we're solving these as if they're 3 separate equations, but we just know we're doing the same 3 steps. So we might as well write them out and do them all one after the other without having to write out all of the left-hand side all over again. And we'll round these off to 2 decimal places as we're writing in the final answers. And you can see the first two comfortably in between 0 and 2 pi. Finally, 7.51215 in our calculators. We times by 2. We add 1. And divide by 3. And just check that that answer does come out as less than 2 pi. And it's 5 point something, so that must be. Okay. That last one trips people up all the time. What people tend to do is find the first answer out of their calculator and then solve the equation. And they would get down to 1.15 and they would put that into their cast diagram and then find multiple solutions of that. It's completely wrong to do it that way. You always start with finding the number out of your calculator goes into the cast diagram, and it's the number out of your calculator you are always finding multiple solutions of. Okay, favourite lower sixth class of mine. It's time for you to get working on this exercise. So I'd like you to, close this video and go straight to it. Thank you.